So today we're going to learn how to do what's called stoichiometry. And stoichiometry is going to be taking all of the mole conversions that we learned already and adding it to the mole to mole ratios that we've been working on for the last couple days. So you probably want your calculator and your pink packet out. So the problem solving strategy we're going to learn today is called dimensional analysis. It's going to take more than one type of problem solving strategy to get through the types of problems that we're doing. So it is not one size fits all, but having a couple tricks in your trick bag for solving problems is going to be super helpful. And this is like learning strategies that are going to help you in physics so you can be successful in physics also. So let's look at this type of problem. It says, how many grams of sodium chloride would be produced from 5 moles of sodium according to the following equation? So here is our 4 steps. Our 4 steps are, first we have to balance the equation. You might not necessarily need to balance every equation. Some equations come to you already balanced. So if they have the coefficients there, they're already balanced. The next it says diagram the information onto the equation. So notice what I did was I wrote down my given underneath the substance that has the numbers and is given to me in the problem. And then I drew an arrow which indicated where am I going? What did they ask me to find? And they asked me to find grams of sodium chloride. So we're going to use our mole map in our pink packet. So our mole map is the one that looks like this. So far, up until this point, we've always been in the white side. Today, we're going to the dark side. This mole to mole conversions, mole to mole ratios that you've been doing the last couple days is taking you from moles of A to moles of B. Notice the only arrow that goes from the A side to the B side is moles to moles. So look at your given and find we're always going to start on the A side. So we're always going to start over here on the white side. So it is moles of A is the spot we're going to start at. And it's asking us to find grams of something else. So if it's a stoichiometry problem, they'll be asking you to find something different than they gave you. That's when you know you go to the B side. So the first thing I'll do is change moles of A to moles of B, and then moles of B to mass of B. So here is what we call a mole map. It is a path we're going to take on our mole card to get us from our given to what is asked for us. So there's 2 arrows. There's going to be 2 conversion factors, and it's a 2-step problem. So write your dimensional analysis. How we do this is we always start with our given and put it over 1. And then remember our pattern. The units that are here are going to be written down here. The units that are here are going to be written down there. There's a pattern to all of our dimensional analysis and a path that will be followed. So then I multiply across the top and I divide by the bottom. Remember, our answers will be in the same number of sig figs as our given. That's where you get your significant figures from, is the given. So I would report my answer as 292 grams of sodium chloride. I'm going to be super careful starting now. You're not just going to write your numbers with units. It's also going to be units and labels. If you do not use units and labels, you'll get this conversion factor wrong. So you're going to come up to me and say, how do I know which number goes where? And I'm going to say to you, well, if you're using your units and your labels, that's going to tell you what goes where. Let's look at a second problem here. Determine the volume of gas at STP that can be produced from 24.7 grams. So the first thing I'm going to do is write my given underneath the substance it is. So I wrote 24.7 grams underneath sodium, and I'm going to draw an arrow to what they asked us to find, which is volume of a gas. So on my mole card, I'm always going to start on the A side. My given was given to me in mass, so I know I'm going to start at mass of A, and they're asking us to find volume of B. So you can see the path you're going to have to take. First, you go from mass of A to moles of A, moles of A to moles of B, moles of B to volume of B. This is my path that I'm going to take on my mole card. I have 3 arrows this time. It'll be 3 conversion factors. So I noticed that grams of sodium needs to be canceled, so I'll put grams of sodium down here. I'm changing grams to moles, so moles goes on top. Then I'll need moles of sodium to cancel, so I'll put moles of sodium down here. Then I'm going to change moles of sodium to moles of chlorine, so I'll put moles of chlorine up here. Then I'm going to change moles of chlorine to liters of chlorine. Now this conversion factor here is the only one that is new and can be a little tricky. So we can look on our mole card and determine what numbers go with what. So this is my grams to moles conversion. This is the periodic table of the elements. My moles to moles conversion is the only time that moles gets a number other than 1. This is the coefficients from the balanced equation. My moles to liters is always 22.4 liters in 1 mole. So now that we've introduced that moles to moles using the balanced coefficients, that's what I'm going to see you make. You're going to put the number 1 other than 1 in all the rest of the conversion factors. You can see that every single conversion factor that we're going to use on this whole mole card, if you look all around here, all the conversion factors we're going to use are going to have the number 1 with the word mole. Only this one in the center, the mole to mole conversion, is the only time you're going to use a number other than 1. Multiply across the top, divide by the bottom, you get an answer of 12.03305,785 liters. Because the given has 3 sig figs, the answer will be 12.0 liters of chlorine. We're going through these so we can see the setup, and then we're going to do examples step by step. Let's look at our last example problem. How many atoms of sodium would be required to produce 67 grams of sodium chloride? So notice we're not always starting with a reactant. So I'm going to put my given underneath the substance that we're talking about. I'm going to draw an arrow to what they're asking us to find, which is atoms of sodium. I'm going to look at my mole map and see my given is in grams, so that's mass. Remember, we always start on the A side. So first I'll change mass of A to moles of A, moles of A to moles of B, then moles of B to particles of B. Remember, atoms is a particle. So here is my path on my mole card. 3 arrows, 3 conversion factors. We look and we see the pattern. Grams of sodium chloride needs to be canceled, so I'll put grams of sodium chloride here. Moles of sodium chloride needs to be canceled, so I'll put moles of sodium chloride down here. Moles of sodium needs to be canceled, so I'll put moles down here. That same pattern is in our problems, all of our problems. Now that I have my units down, I can figure out my numbers. This conversion factor comes from the periodic table of the elements. The number that goes with grams is the mass of sodium plus the mass of chlorine. The number that goes with moles is 1 always. The numbers for this conversion factor come from the balanced chemical equation. Sodium gets a 2 and sodium chloride gets a 2. The numbers that go with this conversion factor, this is Avogadro's number. Mole always gets a 1, and this big giant number, 6.022, times 10 to the 23rd always goes with atoms. Multiply across the top, divide by the bottom. And I get an answer in my calculator of 6.904072553 times 10 to the 23rd. I'm going to round it to two significant figures because my given is two significant figures. So I will answer 6.9 times 10 to the 23rd atoms of sodium. You're now going to be required to use units and labels. All right, now that we walk through the example problems, let's actually do some ourselves. Problem number 1 states, how many moles of copper is required to make 10.0 liters of NO gas at STP? That gas at STP simply means standard temperature and pressure. If it's not at STP, we can't use 22.4. So right now, they're all going to be at STP. So the first thing I'm going to do is find 10 liters of NO. I'll write 10.0 liters at the bottom here. They're asking us to find moles of copper. So if you're given liters, remember, always going to start on the A side. It's going to be volume of a gas. So let's make a mole map plan. So volume of A is what we're going to start with. In this case, A is NO. We're going to end up at moles of Cu, so B is Cu. So volume A, the only place we can go from there is moles of A, and then we'll change it to moles of B. 2 arrows, 2 conversion factors, 2-step problem. My given with units and labels. I need liters to cancel, so I'm going to put it down here. And I'm changing liters to moles. Notice how I'm careful to use units and labels in each of my sections, because this is the one that you're going to get wrong or is going to confuse you if you don't use units and labels. I need moles of NO to cancel, so I'm going to put moles of NO down here, and I'm going to moles of copper. Now let's figure out our numbers. The conversion factor for liters to moles, every time liters gets a 22.4 and moles gets a 1. Now these numbers from moles to moles are the balanced chemical equation coefficients. NO gets a 2, Cu gets a 3. So in your calculator, you'll multiply across the top and divide by the bottom. So we do 10 times 3 divided by 22.4 times 2. Your calculator tells you 0.669642 and a bunch of other numbers that don't matter to us. I'm going to round it to 3 significant figures, so my final answer will be reported as 0.670 moles of copper. Make sure in your answers you have units and labels. Next problem states, if you begin with 55.25 grams of copper, how much water will be produced? So I'm going to put my given underneath, and I'm going to make an arrow to what they're asking us to find. So I start with mass and I end with mass. So I'm going to start at mass of A and end at mass of B. So I'm going to change mass of A to moles of A, moles of A to moles of B, moles of B to mass of B. So in this case, A is copper and B is water. Three arrows, three conversion factors, three-step problem. My given, I need grams to cancel out, and I'm changing grams to moles. Now I need moles of copper to cancel out, so I'll put it down here, and I'm changing to moles of water. I need moles of water to cancel, and I'm changing to grams of water. Now let's go through and fill out the numbers. The mass to moles conversion always comes from the periodic table of the elements. That's the one that goes with grams of copper and 1 mole of copper. Remember, in the grams to moles conversion, moles always gets a 1. I'm going to see you guys throwing the coefficients from the balanced chemical equation all over the place. The only time you can do that is from the mole to mole conversion, which we're doing next. So you look up, and the number that goes with moles of copper is 3. And the number that goes with moles of water is 4. Now we're doing a mass to moles conversion again. So moles gets a 1. Grams gets the number from the periodic table of the elements, which would be 16 for oxygen and 2 times 1.008 for hydrogen. Multiply across the top. And everybody should do these as we're doing the problems. You should do the calculations in your calculator. It's going to save you a lot of problems later. Just make sure you're using your calculator right. And you should get in your calculator 19.75312. I'm going to round to 4 sig figs, and I get 19.75 grams of water as an answer. All the numbers that are in there, so 52.25 times 1 times 4 times 18.016, then press enter. Divided by parentheses 63.54 times 3 end parentheses, then push enter. Number 3, 25 moles of nitric acid. You got to remember your naming here. Remember, the one that starts with H is nitric acid. So we start with 25 moles of nitric acid, and we're asked to find the formula units of copper 2 nitrate. So I'm starting on the moles on the A side. Then I'll change to moles of B, and then I'll change particles to B. Does everybody see where I got that mole path from? Should be looking at your mole map if you're not following along. So 2 conversion factors, 2 arrows, 2-step problem. My given. My first step would be to change moles of nitric acid. Okay, let's work on the numbers. This is the mole to mole using the balanced chemical equation. What number goes with HNO3? 8. What number goes with CuNO3 2? 3. Now down to this one. Now, what number goes with copper 2 nitrate? 1. And then the big giant number goes with formula units. So in your calculator, you're going to type in 25 times 3 times 6.022. We're going to use the exponent function, don't forget. And then we're going to divide by 8. 5.645625. And then forgetting to look over to the right and seeing that there's an exponent there. If you answer this, it is wrong. And let's talk about what's reasonable. You can have one molecule, you can have two molecules, you can have three molecules, you can have four molecules. You can't have 5.65 molecules. You can only have molecules in whole number increments. So if you answer this, tell yourself, I'm missing something, okay? Especially in these types of problems, you expect to have lots and lots and lots of molecules. So to round to 3 sig figs like the given, it's going to be 5.65 times 10 to the 24th formula units of copper 2 nitrate. Okay, last one before I let you go and practice. If 1.9 times 10 to the minus 16 molecules of nitrogen monoxide are made, how many moles of copper are required? So we're going to go down here to nitrogen monoxide, 1.9 times 10 to the 16th molecules is what's given to us. And they're asking us to find the number of moles of copper. So if I'm given molecules, what box am I starting in on my mole card? Particles A is where I'm going to start. Particles of A, which is H2O. And then we're going to end at moles of B. So particles of A, we can change to moles of A, which is always our given. A is always our given. And then we can change to moles of B, which in this case is copper. 2 arrows, 2 conversion factors, 2-step problem. 1.9 times 10 to the 16th molecules of NO is what we're starting with. In order to cancel molecules of NO, I will put it here. And I can change it from molecules to moles. Then I need moles of NO to cancel, so I'll put it down here. And I can change it to moles of copper. Look at your mole card. That'll keep you from putting anything but 1 next to the units of moles in this conversion factor. The ones that come from the balanced chemical equation have to be mole to mole, like right here. Type this in your calculator so you make sure you're using your calculator right. 1.9 times 10 to the 16th times 3 divided by parentheses 6.022 exponent 23 times 2 end parentheses. You should get as a raw answer 4.73265 times 10 to the minus 8th, which makes sense because the 16 is a lot less than 23. So it's going to be less than 1 mole. Round to 2 significant figures, just like the given is 2, for 4.7 times 10 to the minus 8th moles of copper. Remember, units and labels, correct number of significant figures. Okay, so this is an introduction. Now I would like you to spend the rest of the class period, you can work with your friends and work on the stoichiometry assignment. It's stoichiometry practice problems.